Hi, my name's Dr. Natalie Schmitt, and I'm the CEO and founder of WildTechDNA. Now, to address the global extinction crisis and biodiversity loss, we so desperately need to create tools to empower millions of people to contribute in a meaningful way to conservation, both locally and globally. With an investment of $650,000, we can enable global participation in wildlife monitoring through the development of a portable, affordable, and easy-to-use DNA paper-based technology at a scale, cost, and simplicity never previously possible until now. And I'm going to tell you why this will be so impactful. Now, as a conservation geneticist, my life has been focused on the use of genetic tools to monitor and learn more about species that are really difficult to study, such as Antarctic blue whales and snow leopards. These are one of the most powerful non-invasive tools that we have for conservation management. In my work and research around snow leopards, I had the privilege of working with some of the communities in the Himalayas of Nepal. And it was there that I realized that we can't effectively address biodiversity loss without involving everyday people in species monitoring, without including more of the world. And it was around this time that I made a discovery that would change the course of my life. I literally stumbled upon a scientific paper written by a biomedical lab at McMaster University that had developed this simple paper-based biosensor for the detection of bacteria in food and water samples. And I had this eureka moment because I realized that if we could adapt this to wildlife detection, then the impacts in terms of addressing the global extinction crisis would be absolutely profound. So I literally gave up my career, I left my family and my friends, and I moved to the other side of the world to pursue this with this lab. Why did I decide to make such a sacrifice? Well, our ability to detect wildlife from their remains, which is hugely important in terms of conservation management, is still largely lab-based, which is expensive. It takes long periods of time, and it involves considerable expertise, which means that the majority of the world can't be involved in species monitoring. Many developing countries simply don't have access to these types of laboratory facilities. And within these countries, for some, it's illegal to send samples out of the country for DNA analysis. And this is having huge consequences. So the illegal wildlife trade is a multi-billion-dollar problem, but it's the inability of customs officers and law enforcement to be able to distinguish quickly, easily, and inexpensively between a legal and illegal sample that is one of the biggest issues in the enforcement and prosecution of the illegal wildlife trade. We can now detect endangered species through their fecal samples. But unless we can identify those fecal samples on the spot, then we actually risk collecting samples that are not from our target species. And believe me, at the very least, this can have huge financial implications for NGOs, for governments, for industry, and for academic institutions. If there's one thing that this pandemic has taught us, it's how important it is for us to be able to detect wildlife pathogens on the spot quickly, easily, and inexpensively. The consequence that is very dear to my heart is that unless we can empower everyday people to contribute to species monitoring, then we are effectively eliminating the most important component to successful conservation there is. So what would make a species detection technology truly effective for mitigating biodiversity loss? Well, we know it must be sensitive and specific for our target species, but it ideally needs to be portable, affordable, and easy to use. Now, there are devices already on the market, such as portable sequencing machines, but they suffer from the same problems that we see with traditional laboratory approaches. So we want to develop a technology that is specifically aimed at non-experts, that is more inclusive. And this is a technology based on over 15 years of foundational research into point-of-care diagnostics at McMaster University. We're starting with caribou as our model species because it's a very important species in Canada, particularly to industry and government that need to ensure that their developments are not encroaching on caribou migratory routes. So the basic premise behind this technology is that it will consist of a platform very similar to what you see here, and disposable paper strips that include all the reagents necessary for the detection of your target species, dried and printed onto the paper surface. So once the DNA is freed up in solution, it's applied to the paper surface. If it belongs to your target species, it will initiate an amplification reaction, which is then linked to a color change. There is nothing like this on the market at the moment. No sequencing required, no heating required, and because the reagents are dried and printed onto paper, it keeps this technology really affordable for where it's most needed in the world. We're still about 2 years away from developing a prototype, unfortunately due to COVID delays, but this has actually been a bit of a blessing in disguise for us. Because, I mean, we've all seen firsthand just how these rapid tests have revolutionized the speed, the process, and cost of COVID detection. So we're taking advantage of these developments in detection methodologies to help make our device faster, more specific, and more sensitive, enabling us to attack biodiversity loss at a scale never previously possible. So this is a really exciting time for this type of technology. And despite still being in the research and development phase, we've received a ton of recognition and support. So to expand this technology beyond caribou to many important species and applications around the world, we're partnering with the South African government, the Wildlife Conservation Society, and all 12 of the snow leopard range countries, as well as the Earth Biogenome Project that had the ambitious goal of sequencing all the plants and animals of the world in the next 10 years. We've received a plethora of media recognition. I was recently awarded the Explorers Club Top 50 People Changing the World that the world needs to know about. But the icing on the cake is that we were recently recognized by CITES. CITES are a global multilateral treaty that protects endangered species in trade, and the recognition really doesn't get much bigger than this. And I pinch myself every day that I get to work with some of the giants in biosensor research at McMaster University, as well as 2 incredible postdoctoral fellows, a PhD student, but we still need to find 2 more researchers to make this work. So I've mentioned there are clear applications to conservation, but there are also enormous applications commercially, applications that address global issues with billion-dollar costs. And our idea is to use these commercial applications to help subsidize the conservation applications at the grassroots level. And we are finalizing an intellectual property agreement with McMaster University to give us exclusive worldwide rights. So with a $650,000 investment, we want to accelerate this research. We want to combine all the components into one prototype device, and we want to build a robust go-to-market strategy to capture the most pressing opportunities. We have an opportunity here to quickly become world leaders in conservation rapid diagnostics. I bet you've never heard that terminology. That's because it's completely new. A market niche still in its infancy, but with huge positive impacts for conservation, managing biodiversity loss, and enormous commercial applications. I really hope that you will join us in helping to make this a reality, and thanks to NOAA for giving us this opportunity. Thank you.